Dart Skill presents representing data. There are several ways to represent data using diagrams. In this video, we are going to explore a couple of them. Here comes an example. Given below is a horizontal graph. So this is horizontal. The graphs are going this way, showing the number of students playing different games in a class. So we have cricket. This is cricket, just in case you cannot read it. And then we have football. And then we have rugby, followed by tennis and squash. And each one of these is represented by a horizontal bar. Reason why this is called a bar graph. So you have a bar for football, you have a bar for cricket, you have a bar for rugby, a bar for tennis, and a bar for squash. And the length of each bar is actually proportional to the number of people who are playing that game. For example, if you look at cricket and tennis, the two bars have the same length because there are 4 people who are playing cricket against 4 people who are playing tennis. So the numbers are also equal. Similarly, because there are only 2 people who play football and 2 is exactly half of 4, the length of the football bar is supposed to be exactly half of the length of the cricket bar, or for that matter the tennis bar. And in the same way, because there's only 1 student in the class who play rugby and 1 is exactly half of 2, the length of the rugby bar and the length of the squash bar, only 1 student plays squash as well. So the lengths of these 2 bars, rugby and squash, have to be exactly equal to half the length of the football bar. And this, like I said, is called a bar diagram or a bar graph. So you can look at the bar diagram and answer questions like how many students play cricket, how many more students, let's say, play tennis than rugby and squash combined, and so on and so forth. Let's look at another one. The graph below shows a survey done by a teacher from 2 classes. The survey was on the career preference of students. So a group of students were asked what they would like to be as a professional, and some of them said they wanted to be a doctor. 7 of them said they wanted to be a doctor. 17 of them said they wanted to be a lawyer. And then 13 of them said, okay, I want to be a nurse. And then 21 said they wanted to be scientists. And finally, 28 of them said they wanted to be teachers. If this looks clumsy, feel free to write these names on the bars themselves. So you could write doctor over here, lawyer over here, nurse over here, scientist over here, and teachers over here. Let me also put outline around the bars, especially the teacher bar. Okay. So this is for nurse, and this one's for lawyer, and the first one is for doctor. And this again is a bar diagram or a bar graph. Notice that the bars in this case are vertical as opposed to horizontal bars in the previous example. And then obviously you can look at these numbers and answer simple questions like how many people want to be nurse, 13, how many people want to be doctors, 7, and so on. If you want to find the total number of people who were surveyed, you just need to add these numbers up. So 7 plus 17 is 24, 24 plus 13 is 37, plus 21 is 58, plus 28 is 86. So we could conclude that there were 86 students from the 2 classes combined who were surveyed by the teacher. Let's now discuss another method of diagrammatically representing data, and that's called a pie chart. And to do that, let's go back to the previous example on bar graph. So back to this example on favorite sports or the number of students playing the different games, cricket, football, rugby, tennis, and squash. And obviously this is a bar graph. Now there's something called a pie chart. And that's just another way of representing data in which the whole thing is represented on a circle. And starting from the center of the circle, we make slices of the pie for each of the different types like cricket, football, rugby, and so on. And the size of each of these slices is proportional to the number of people who play that sport. Just like on a bar graph, the size of the bars are proportional to the number of people who play that sport. So starting from a radius, it's about how many degrees you want to give to each one of these slices. Now we know that the total angle around the circle is 360 degrees. So to find the degree measure of each of these slices, you want to figure out what fraction of the total data should go to that slice. So if we look at this bar diagram, the total number of students is 4 plus 2, that's 6, plus 1 is 7, plus 4 is 11, plus 1 is 12. So 4 out of 12 play cricket. So that's a fraction. And therefore, that's exactly the fraction of the whole circle that should go to the cricket slice. So you want to multiply this with 360 degrees to find out the angle you want to give to cricket on the circle. Hope that makes sense. 4 out of 12 is 1/3, so you have 1 on the top, 3 on the bottom. 1/3 of 360 is 120 degrees. So we have pretty much all the way from start to round about this point. And we could say this is for cricket. And that's the same amount for tennis because they have the same numbers. 4 out of 12 times 360 again. So this angle out here for cricket is 120 degrees. And we have another 120 degrees. So this is another 120 degrees. And that's for tennis. Similarly for football, this is going to be 2 out of 12. 2 out of 12 times 360 degrees. And that is 60 degrees. If you simplify this, you get 60 degrees. Now, if you take out 120 and another 120 from the whole circle, that's 360. So this remaining portion is another 120. So 60 degrees is exactly half of that. And therefore, it's going to be round about the halfway mark. I'd go for around this point. So that goes for football. That's a 60 degrees. And we have another 60 degrees to complete the full circle that is equally divided into rugby and squash. So it's pretty much halfway through this line, the length of this line. So we have a 30 degrees here, 30 degrees, and another 30 degrees here. If you add up all the angles, you should get 360 degrees. And this one, like I said, one of them is for rugby and the other one is for squash. So this whole data from the bar diagram has been transferred to the pie chart.